Good. So what we want to talk about today is the subject of fractions and operations with fraction. Right? So we want to talk about fractions. And we all know what's a fraction. A fraction is part of a whole. You have fractions, let's say, okay, you have a fraction 1/2. You call that the numerator, and this is called the denominator, right? And what we'll deal with, we'll talk a little about how do you add fractions, how do you subtract fractions, how do you multiply fractions, and finally, how you divide fractions, right? We'll go a little deeper, and instead of just fractions, we'll talk about how we can add, subtract, multiply, and divide something called mixed numbers, right? So you have like, okay, 1.5. This is an example of a mixed number, right? And why they call it that is that there is a whole number component, right? And then there is a fraction component. So that's why they call it a mixed number, right? So how do we deal with that? How do we add? How do we subtract numbers of that sort? How do we multiply? How do we divide? And so on. All right, so we'll spend a little time on that this evening. So let's start with addition. Addition of fractions. Right? So let's take examples, You want to add half plus 3/4 plus, let's say, 1/3, Now, you can add two fractions, and I want to just deviate from this one to come to something simpler. Let's say you want to add a half and another half. If the denominators are the same, you can simply add the numerators and you get 2/2, which is you cancel down, and that's another. Well, remember, I'm assuming that you know a little bit from primary school or what, right? You cancel down the 2 and the 2, so 2 1s, 2 1s, and you end up with 1/1, which is 1, right? You want to do it that way. Or you could have said 2 divided by 2 equal 1, 2. Right? Good. So when you have two similar denominators, let me do maybe another example. You got a quarter plus another quarter, right? When the denominators are the same, you can simply add the numerator. So you get 2/4, which can cancel down or simplify to 2 1s, 2 2s, and you get a half, right? So that's when you reduce a fraction. Good. So we're going to extend that to this here. So we have 3 fractions to add. But the trouble is that their denominators are all different. What do we do then? What do we do? Well, what we want to do is we want to write these 3 fractions with a common denominator, right? And before we can do that, there is something called the LCM. Probably you heard this term before, the LCM that you have to find. And the LCM of 2, 4, and 3 is the LCM that you want, right? And, well, for this, it shouldn't be hard for you to look at it and see that, well, the LCM of 2, 4, and 3 would be 12, right? When you have bigger numbers and so on, harder numbers, well, there's a little method you can use to find the LCM, right? Maybe I can just touch on that here. Give me a second. So let's say you want to find the LCM of 2, 4, and 3. The method has to do with writing the number as a product of its prime factors, right? So like 2 is equals to 1 by 2, right? 4 is equals to 2 by 2. And 3, well, it's 1 by 3, right? 1 by 3. So here, the three numbers we're dealing with, these are the factors. So, well, you're not going to consider 1, right? Don't forget 1. The highest power of 2, you get 2 square. And, well, all the rest is just 3. And the highest power of 3 is 1. So you just use those highest powers, right? So 2 square, which is 4 by 3, equal 12. That's a simple way of finding the LCM, right? You use the highest power of each factor that you see here, right? The highest power of each factor that you see here. No need to look at the 1, because remember, 1 times anything is the same thing, right? So 1 doesn't change anything. But we see 2, we got 2 squared. That's the highest power there in all 3 of these factorizations, right? You got 2 squared, so you use that in your LCM. Down here, you got a 3, right? So you use 3 to the 1 power. Maybe I can illustrate it with some bigger numbers. Let me do another one, right? Not We can come back to the problem just now. I know you're impatient to see the problem solved. Let's take 3 numbers. Let's say we want to find the LCM of let me go with some biggish numbers, right? Let me go with 12, 15, and let's say 30. Right? Some people have the ability to just watch this and tell the answer, right? Let's see. So we got 12. We want to write it as we call as a product of its factors, right? So it's going to be what? 2 multiplied by 2 multiplied by 3, right? That's 12. 15, we got 3 multiplied by 5. And 30, what would that be? 2 by 3 by 5 will give you 30. Good. And you look for the highest power of each of these factors. So what's the highest power of 2? Because there are three factors we see in play here. 2, 3, and 5, right? So the highest power of 2 is 2 squared. 2 squared, right? Multiply by, well, 3 now. Well, the highest power of 3 is just 1, 3 to the 1 power. Multiply by, highest power is 5, right? Sorry, is 1 on the 5. So your answer is going to be what? 2 square is 4, 4 3 is 12, 12 5s is how much? 60, right? So that's your LCM. All right, so that's one simple way to find the LCM of 3 numbers. But you can watch 2, 4, and 3 and know that 12 is your LCM. So what you're going to do now, you're going to write each of these numbers here with that common LCM of 12, right? So what you do to do that? You divide 12 by 2. So 2 into 12 is 6. Then you multiply by the numerator. You get 6 plus 4 into 12 is 3. 3 times 3 is 9 plus 3 into 12 is 4. 4 times 1 is 4. And then you add up all of that, right? When you add up all of this, what will you get? 6 and 4, 10, and 9, 19 over 12. Now, this is what we call an improper fraction. You have to convert that now to what you call a mixed number. So it's 1 and 7 over 12, right? That's your answer. So addition is very simple, very, very simple. You try to write all your fractions with a common denominator, right? And then you you add up the numerators. Very often you might find that you have an improper fraction. You need to convert your improper fraction to a mixed number, right? You follow this one? Everybody follow? I need some feedback here.
Yes, sir.
Yes, sir.
Good. All right. Not going to do too much of that. Let's go to subtraction of fractions. Subtraction of fractions. You know what? I should back up. I didn't do one with a mixed number. Sorry. Let me do one with a mixed number. Kind of jumping the gun there. All right, let's say we have to add 1.5, 2 3/4, and 1 1/3. Let's say we have to add those up, right? So some people do it differently, right? One of the ways we can do is we can take all three of these, change them into what we call improper fractions, and then add them, and then change it back to mixed numbers, right? So let's do that. So you multiply the denominator here by the whole number, right? And you add that 1 on top. So you get 3 over 2, right? Why that works is that 1.5. Let me put a little explanation here. 1.5 really means this: 1 plus a half, right? If you want to write 1 with a denominator of 2, it's really this: 2 over 2 plus 1 over 2, which is 3 over 2. Some smart Alec now recognize that, you know what, there's a shorter way to do this. 1.5, you just multiply this 2 by the 1, add the numerator, and put it over the denominator there, right? So no need to do all this long process. Just this is a shortcut. So plus, what is this now? 2 4 is 8, and 3 is 11 over 4, plus 1 3 3 plus 1 is 4 over 3, right? And then we find the LCM again. Our LCM will be 12. 2 into 12 is 6. 6 3 is 18, plus 4 into 12 is 3. 3 times 11 is 33. 3 into 12 is 4. 4 4 is 16. And you add up those. Help me with those big numbers there. Let me see. 18 plus 33 plus 16. We got 67. 67 over 12, which is the same as 5 and 7 over 12. Hmm?
Still doing the calculation, sir. 1 minute.
Yeah, I think that's it.
Yes, sir.
Yeah. The alternative thing, right, is to, as I was telling you just now, was to do this. And you probably, maybe you were taught this in high school too. You were taught this in high school. What you could do, you take the whole numbers, and add them up. So 1, 2, and this one is 4, right? 4. And then you add the three fractions, right? So you get 12 being your LCM. 2 into 12 is 6. 6 1 6 plus 4 into 12 is 3. 3 3 is 9 plus 3 into 12 is 4. 4 times 1 is 4. In this case, you deal with very small numbers, right? So you have 4 and, what was it? 19 over 12. Now look at what happens here, right? You basically have a mixed number where the fraction part is actually an improper fraction. So you have to convert it to a mixed number. Remember, this means 4 plus 19 over 12, right? That's what it means. So this now becomes 1 and 7 over 12. And now you add the 4 and the 1, you get 5 and 7 over 12, right? So some people do it like that. Good. So let's move away now from the addition part. That's a little revision here. Let's do some subtraction now. Subtraction. Right? So you have let's go with, all right, 4/5 minus 1/6. Let's just say, you have something like that. Very similar to addition, in just that you're going to do subtraction now. Find the LCM of 5 and 6, which is 30, right? And 5 into 30 is 6. 6 4 is 24. Minus 6 into 30 is 5. 5 1 is 5. So you end up with 19 over 30. That's it. Am I right? 5 from 24 is 19.
Yes, sir.
Good, right? Simple as that. Let's deal with a mixed number. So you have, all right, let's do it this way. Now let's say we go with let's say 1 and 1/6 minus 4 over 5. Look at that. Right? So I'm gonna do it two ways. What we could do is change this to a improper fraction. So you get 7 over 6, 7 over 6 minus 4 over 5, right? Find your LCM. 30 again. 6 into 30 is 5. 5 7 is 25. Okay. 5 into 36, it was 24. So you'll get what? 11 over 30. Right? That's one way. You notice you're dealing with a few big numbers, Not everybody might be comfortable with that. And there's another approach I remember when I was a kid. We were taught this, right? So we were taught another method where you have the 1 down here, and then you're subtracting 1/6 minus 4/5, right? So you find your LCM. 6 into 30 is 5. 5 1 is 5 minus 5 into 30 is 6. 6 4 is 24. Now you can't take away 24 from 5, right? So what we do normally, okay, put a 1 here, right? You take the 1, and that is equivalent to, this 1 is equivalent to 30 over 30, right? So you add this 30 to the 5, right? So 30 plus 5, you get 35, right? So 35 minus the 24, we end up with, of course, when you take the 1 from here, you end up with 0 here, right? And this 30 converts to, it's really 30 over 30. So you add this 30 on top there to the 5. You get 35. 35 minus the 24 gives you the same 11 over 30. That's your answer there, right? But this is a little complicated for a lot of people, right? Seeing this 1 as 30 over 30, right? So it's like, let me clarify a little more. It's like, okay, what you have here, you have 1 plus 5 minus 24 over 30. Good. So this one is like 30 over 30 plus Okay, 5 minus 24 over 30, right? So you can write all of this now in one, right? Um, so you'll get 30 plus 5 minus 24 over 30, which gives you the same 11 over 30, right?
So in other words, the whole number is always equivalent to the denominator.
Over the denominator, yes. Not all.
Okay.
Let me change this to a bigger number. Let me change this to, let's say you have 2 there, right? So let's go, all right, I'll change it to 2. So let's have, all right, 2 and 1/6 minus, what was it, 4/5, right? So, okay, all right. So we end up with 2 plus, um, what was it, 25 minus 24, right? Good. So what you'll do now, you take 1 from here. You take it as this, right? You take 2 and you split it up like this. 1 plus 1, right? Plus the 5 minus 24 over 30. This one, you're going to write as 30 over 30 plus 5 minus 24 over 30, right? And you do the same procedure, but the 1 remains there. So when you finish, your answer will be 1 and 11 over 30. Right? So not always will you have, remember, you have more than 1 here now, right? So you only need 1 to convert to help this 5, right?
Yeah, I understand.
Yeah. But all of this will be averted if you just change this to an improper fraction. Change it to an improper fraction, and what happens? You get 2 6s 12 and 1, 13 over 6 minus 4 over 5. The only trouble here is that you get some bigger numbers to deal with, right? So 6 into 30 is 5. 5 by 13 is how much? 65, I hope. 5 into 30, so this is 24, and you subtract, what do you get? Um, 5 by 30 minus 24, 41. You get back 41 over 30, which is, what is it? 1 and 11 over 30, right? The same answer. Following so far?
Yes.
Yes, sir.
Yes, sir.
All right. So let's go to a little bit of multiplication. Right? You have to multiply 2 fractions. Let's say you have okay, 3 over 4 multiplied by, let's go with 8 over 9, something like that, right? You can cancel any numerator with any denominator, right? So you can cancel 3 1s, 3 3s, 4 1s, 4 2s, and then you 1 by 2, you put 2 there. 1 by 3, you get 3 there, and you finish. Very simple. You can cancel any numerator with any denominator. When you have mixed numbers, things get a little complicated. So you got 1 and let's say a half multiply by, let's go with 9 over 10 maybe. Yeah. No, let me not go with 9 over 10. Let me go with 10 over, let me go with, excuse me with that. Uh, let me go with maybe Um, I'll go with 4/5. Let's go with that. So what you do, you want to change this to an improper fraction. So you end up with 3/2 multiplied by 4/5. This can cancel with that. And you end up with anything else can cancel? No. We end up with 6/5, which is 1 1/5, right? When both are mixed numbers, you just change both to improper fractions and you multiply, right? You try to cancel um, any numerator with any denominator. Following so far?
Yes,
Yes,
sir.
sir.
All right. I think this is all revision for you, right? If you have, of course, if you have a calculator that can do division, that can do fractions, you don't need any of this, right? Unless you are teaching it to maybe elementary school, right? But if you don't need that and you have a calculator to do the job, well, why are you sweating over the arithmetic of fractions, Make use of the technology, right? Most of you, I don't think very many of you will get into teaching elementary school. Nobody wants to teach at that level. It's very difficult to deal with the little children these days, right? So
Yes,
most of
sir.
us, huh? You're a teacher?
No, yes, sir.
Or you teach at the elementary school, at the primary school?
No, I'm about to apply for lower level.
Oh, okay. And you will need the skills. Of course, when you get into college, they'd have to take you through the paces. As a matter of fact, you would have to go down to the level of the students now and understand how they think at that level and how to introduce fractions to them. You'd have to use a lot of pictures and aids, and so for them to understand fraction, what you mean by 1/2, what you mean by 1/5, what you mean by 2/5. You'd have to get onto that, right? But that's not for this course. But I'm saying,
Yeah.
if you have to teach that level, you'd have to learn the finer things. I don't think that's the purpose of this course, right? Um, but when you join college, you're going to learn those things, right?
Okay, sir.
So division now, let's say you have to divide, all right. Okay, 2/5 divided by, let's say, give a wild number, 3, right? So dividing by a fraction is the same as multiplying by, oh, sorry, it's supposed to be 2/5, 2/5, multiplying by the reciprocal, right? So they figured that out um, long ago, right? So you just switch over the 3/1 there, and you end up with, well, nothing can cancel. If something can cancel, you will cancel. You'll get 6/5, which is 1 1/5, right? If you're dealing with mixed numbers, let's say you get 1.5, or sorry about that. 1.5 divided by a quarter, right? All you do, you change this to a improper fraction. You get 3/2, and you change this sign and flip over. You find the reciprocal of 1/4, which is 4/1, and then you cancel 1, 2, and you end up with 6/1, which is 6, right? Good. Then there's there's that relationship between, just to move away a little from the arithmetic of fractions and get into, okay, how do you change a fraction? Change fraction to decimal, and vice versa. How do you do that? Let's say you have 1.5. Let me start with half. Half. How do you change that to a decimal? Anybody? You simply divide the 1 by the 2, right? You can do it the long way using pen and paper, or you punch it in the calculator and you will get 0.5, right? You just put 1, that is what this line means, divide, right? 1 divided by 2, that's what it means, and you get that. If you have to convert 0.5 to a fraction, right? There's a shortcut where this is what you do. You put the numbers behind the decimal here, right? On top here. You put a 1 for the decimal point, and each number, each digit that is behind the what you call it, the decimal point, you put a 0 for, right? So 0.5 is the same as 5 over 10, and then you reduce that, right? 5 ones, 5 twos, and you get a half, right? So it's good to know this conversion, because if I mix up, if I tell you, right? If I tell you, watch, let me just show you a type of question I can very well ask, right? What's this one? Somebody write up on the screen there. Yeah. If I tell you, right, to arrange the following numbers in ascending order, right? I give you the numbers. I say, all right, 1.5, 1.35, you know, 1 and 4/5, 1.47. You know, I ask you to arrange these. You'll have to write all of them either as a decimal or as a fraction, right? And then you can pick out which one is the smallest, and then you go right up to the largest. Isn't that so? So you might take this 1.5 and you get what? 1.5. Then you get 1.35. Then this one will be 1.45 is about 1.8. And then 1.47. And then you look at now, okay, they all got 1 on them. But then the smallest number here is a 3. So you get 1.35 is the smallest. Then I think it's this one here, 1.47. And then the 1.5. And then the 1.8, right? So from the lowest to the highest. Right? So you can be asked all manner of questions, you know, when it comes to fractions and decimals, and you want to know how to handle them, you know. Your best ally would be your calculator to help you to convert one to the other, and so, right? If you know to use your calculator well. And in this day and age of modern technology, right, there's nothing wrong with you learning the technology very well, right? And using it appropriately, right? Good. So now that we touched on a little bit of fraction there, I want to move away from that, because we finished with the algebra, the arithmetic aspect of week 1 there, right? And I wanted to move over to some things on week 2, right? So I want to introduce you to a little bit of algebra, intro to algebra, right? And basically, I mean, that whole branch of mathematics that deals with algebra, it's to help you to start thinking abstractly, to be able to reason, right? And to develop your sense of logic, right? And in algebra, what is done is we try to model real world problems, not necessarily real world, but problems in general. We try to model them using numbers, right? And in our problems, very often, what we want to find out is unknown, right? And therefore, what we do is set up what we call variables. Variables, right? So let's say, okay, you're dealing with, all right, you're dealing with oranges and cherries, right? Now, we don't want to do mathematics with these whole words inside, do we? Right? So what we want to do is we want to kind of reduce this matter of oranges to simply a letter. And same thing with cherries, right? So the number of oranges, we can say the number of oranges we can represent it with the letter O, right? Similarly, the number of cherries we can represent it with the letter C, right? So if you are dealing with a problem, maybe with, okay, maybe you're a vendor, or we're dealing with a problem of a vendor selling oranges and cherries, and maybe they have to model a problem, that, all right, if you were to, let's say, okay, not just the number of oranges, maybe you deal with the number of pounds of orange or the number of pounds of cherry that the person is selling, So, all right, 5 pounds of oranges will be 5O, you know. Um, 6 pounds of cherries will be 6C, and if the person, okay, spends, um, all right, $1,000 to buy this, right? And then you say, well, all right, if the person sells now a pound of orange for so much and a pound of cherry for so much, how much money will they earn and what will be their profit? And so, so you have a way of relating how much orange. I guess this O kind of confuse you. You might think this is 50, right? This is an O, right? And the amount of cherries we represent with a C, right? So in algebra, that's what we try to do, right? We try to represent variables with letters, right? And that's why you see lots of times you see videos or you watch on the internet, you see a lot of strange symbols. All that is happening there is basically symbols borrowed from Greek and Latin and all kinds of places. And that's why you see symbols like alpha and beta and gamma And you see in that summation, right? You see in that, you see in the integral symbol. They're all borrowed from, different languages and so, right? And well, we use them in algebra, and there are other branches of mathematics to represent numbers, right? Um, good. So what we want to be doing now is um, we want to actually see, well, okay, what are some operations we can do in algebra, right? And we'll go right back to the basics again: addition, subtraction, multiplication, division, right? And we'll also talk. It's not a mathematical operation, but um, it's a process, that we'll also deal with. Substitution, right? In algebra, they have some rules governing these operations here, and they're a little strange. Not everybody can grasp them very easily, right? Like addition, right? Okay, let's say we talk about oranges and cherries, right? We simply can't add these further, right? You can't add O and C further than that. You just have to write them like that. But if you have, okay, 2O plus 3C plus 5O minus C, you can actually add and subtract, right? Look here. We can add the O's together and you get 7 O's, right? And the 3C minus the C becomes 2C, right? So the similar ones we can add and subtract, right? But the dissimilar one, we cannot simplify that further. We can't say, oh, this is 9OC. No, we just can't add two different variables, right? We just can't. However, we can multiply and divide any variable with any variable, right? Let me just show you that. You can multiply, all right, let's say you have 2O and you multiply by 3C. Yes, you can have 6OC. You can have that, right? It's funny. You can divide it to, you can have 2O divided by 3C. You can write it as this. 2O over 3C. So in algebra, you can't add dissimilar variables or subtract them, but you can multiply and divide them this way. Get that? Then there is algebraic fractions. Algebraic fractions, right? And these, well, it's a challenge for a lot of people, but you can add and subtract, multiply and divide them very much the way you do fractions. Let's do a few examples. Let's say you have a quarter x plus, all right, let's go with 1/3 x. Now these are similar terms, right? They all both have x. So you can actually add them the same way you will add fractions, right? So you go with, all right, you can do it both ways. You can take this x and put it on top there. Some people do that. X over 4 plus x over 3. Find LCM 12. 4 into 12 is 3. 3 times x is 3x plus 3 into 12 is 4. 4 times x is 4x. And you end up with 7x over 12, which you can also write 7 over 12x, right? Some people do something else, right? And this is what they do. Shift this a little. And what they do, they make use of something called factorization. They take the x outside and they add the fractions separately. So they do that. They factorize out the x. They take out the common thing, right? Put it outside using what they call the distributive law. The distributive law, you all remember that? Let me put it here. So if you have AB plus AC, that's equivalent to A bracket B plus C, right? So the distributive law you can use to take this and expand it to get that, or you can take this and factorize and get that. So this is that process where you take something like this and you make it into that. So we have here two expressions, both with a common factor x. We pull that to the front, and the fractions is left in there, and then we add up, right? And when you add up in there, you will get x times, well, the bracket will add up to 7 over 12. You write that as 7 over 12x. Right? So you add, if it was subtraction, you do the same thing, right? You do the same thing, right? So I guess you can't take away a third from a quarter. You'll have a negative, right? But let's say you go with, okay, 1/3 x minus a quarter y, sorry, quarter x. They have to be of the same variable before you subtract, right? Again, you can pull the x out, and you have 1/3 minus a quarter. You do what you got to do there, right? So your LCM is 12, 4 minus 3. And you end up with x times, this is what? 1 over 12, which is 112x, right? So whether addition or subtraction, you can use that to add or subtract similar terms, right? The terms got to be similar. If you're dealing with x, all got to be x. Right? You're dealing with y, all got to be y before you can add and subtract them. Of course, they have these very complicated ones, right? They have complicated ones like, okay, what is one? A half AB plus 1/3 A square B plus, let's say, another half AB, let me go with, minus a quarter A square B. Now, you have to look for similar terms. So this half AB can be added to that half AB. And you hear people use terms like this. They say, group the like terms. So you can group them up. Half AB plus half AB. These are similar, so you can add them up, right? And then the other ones, okay, 1/3 A square B and a quarter A square B. Those are similar, right? So we can put plus 1/3 A square B minus a quarter A square B, right? And you will work it out the same way I showed you earlier. These two will add up to be AB plus, down here you can take out A square B, and inside the bracket, subtract the quarter, right? And you get AB plus A square B times, I think we worked it out over here, 1/12 you will get. So you end up with AB plus 1/12 A square B. See? So not every time it'll be nice like only X and Y. You can get a whole sort of a whole lot of powers and so involved, right? So that's a little introduction there to algebra, how you can add the like terms, how you can subtract like terms, how you can multiply like terms, how you can divide like terms, Let me do maybe one more multiplication and division and so forth. Let's say, all right, you have A, B multiplied by A square B, even though they're not similar, you can still multiply, right? So you multiply a by a squared gives you a cubed. B by b will give you b squared. See that? If you have to divide, let's say you have to divide a squared b divided by ab, right? You can do this. You can write them, okay, a squared b over ab, and you cancel, right? B into b1, b into b1, a into a1, a into a squared will give you a, and you end up with a as the answer. All right, so that's a little bit of division there. Following so far?
Yes, sir.
Okay.
Yes, sir.
This is what, like revision for you from high school? You remember these things from high school?
Yeah, most of it.
Great. Great. Yeah. So we got one last thing for the evening. I don't want to overfill your brains, you know. I know you all have a certain capacity for concentration and so, you know. After this one, if you want us to take a break and go again, no problem, right? So let's deal with the matter of substitution. I spoke about substitution, right? And in algebra, in most of the mathematics you'll study, right? Whether you study business, whether you go and you study any of the sciences and so on, formulas are all over, right? Like if you, let's say you're in the area of business and you hear about, all right, the amount of money you will accumulate if you invest a certain principal at a certain rate of interest for, let's say, T years is given by this formula. So here you have, you notice again, letters, right, which we call variables, right, representing numbers, right? So those are all going to be numbers. So let's say somebody says, you know what? If you invest a principal amount of, let's say, all right, $10 million, $10 million in a bank, and the bank offers a rate of, and I think no bank offers more than 3%. Well, let's go with 3%. I think some fixed deposits are like hovering somewhere around 3, right? And you do it for, let's say you do that, right? You put in your money there and somehow, I don't know, you get 10 million. Let me go with a more realistic amount, right? Let me go with a more, I'm being unrealistic. Let me go with a more realistic, $1 million, $1 million. At 3%, and let's say you leave it in there. Oh, you're young and you say, man, look, I leave it in there until I am 25, right? So let's say you are 16 now. All right, let me say 15. We'll go 10 years. T equal 10 years, right? How much money will accumulate over this period of time at this rate, right? And this 3% is what you call, they're compounding it every year, right? We're not complicating things where they're compounding it every 3 months, because most banks do that, right? They compound it every 3 months. Some banks, yes, most of them do it, well, say every quarterly. We are not going to use that complicated one, right? We're going to use the simple one. You're saying, man, let's say they compound it every year, right? So you'll have to substitute all these numbers in this formula, right? So A, then the amount accumulating will be your $1 million. 1 plus 3 over 100 to the 10th power. You'd have to do that in a calculator. Can somebody do that and tell me?
$300,000, sir.
No, it can't be 300,000. Think what you're saying. So you get
Or is
1
it
million.
1.3?
All right, all right. All right, roughly that, right? Yeah, roughly that. You're not wrong there. Yeah, you have to get more than $1 million. You can't invest $1 million and get less than $1 million, right? So you get $1,343,916, right? So imagine this, right? You can, if you invest $1 million at this rate, you will get $343,916 after 10 years, right? You understand? So you notice here, you have to substitute in a formula. You have these numbers, you have a formula, and you have to learn how to substitute in a formula. So that's a very important, skill that you need to do, right? You need to know and master, being able to substitute in a formula, right? Because you're gonna meet all kinds of formula in algebra, right? And all the areas of study, right, that you have. Good. I covered most of what we wanted to cover this evening. So I'm thinking of the wisdom of going into factorization now. Do you want us to take a break and then we touch on factorization? Now it's 6:30. Take a 10 minutes break.
Yes.
All right. Good. So I'm going to pause the recording. Yeah. So you want to look a little at factorization. Factorization, right? And we're talking here about factorization of algebraic expressions. Later on, we'll see how this can be a method to solve a certain type of equation called quadratic equations, right? When we talk about factorization, what we really mean? Well, we really mean to write an expression as a product of its factors, right? And to go back to, let's take, we were talking about LCM, and HCF and so, right? And part of the process was to write a number, let's say a number 12, as a product of its factors. So you write it as 2 times 2 times 3. See? So you have factorized 12 there, right? Well, the same thing can be true of algebraic expressions. We can actually factorize them. For example, let me give you a couple of examples. Let's say you have AP plus AQ, right? This can be written as A bracket P plus Q. Now, how did we get here? How did we get here? And this now is what we call the factorization of this expression. Notice it's as though A multiplies P plus Q. So these are factors of this expression. A is a factor and P plus Q is a factor, right? Well, how do we go about factorizing? Well, what we do, we make use of what we call the distributive law. The distributive law. right? And we all know the distributive law like this. We know it, okay, A bracket B plus C is equals to AB plus AC. We all know it that way. We all know that we can take this and multiply out and get that. But the process of factorization is the opposite. We're actually taking this and getting that, where we're looking for the common factors, or I should venture to say the highest common factor, HCF. We're looking at the highest common factor, and in this case, it's A. It's common, so we pull it to the front times B plus C, right? And that's what we're making use of. So this whole process of factorization is making use of the distributive law, right? And that can help us to factorize a lot of expressions, right? We're going to see a number of types of expressions that we can factorize, right? Let's take a few. Let's say we want to factorize, okay, factorize 2x squared plus 3x. Well, the highest common factor here is x. It can be x squared because we can divide x by x squared. So we bring x to the front, and you have 2x. 2x squared divided by x will give you 2x. 3x divided by x will give you 3, right? So we look for the highest common factor. In this case, it's x, right? It can be x squared because x can be divided by x squared, but x squared can be divided by x. X can be divided by x, right? Keep that in mind. And how do I end up with these things in here? If you're not certain, take, okay, 2x squared over x divided by the x in front here. So x1, okay, x there, you end up with 2x, and that's what you put here. 3x divided by the x in front. 3x divided by the x gives you 3, and that's how I get 3 there, right? When you do a lot of these, they become second nature to you. So let's take another one. Let's say you want to factorize negative 2x squared minus 6x. Now I know previously when we talk about HCF, highest common factor, you only think of the positives. But we're gonna break the rules a little as you get up into mathematics, and so you see that we waive the rule, and we're gonna say that the HCF need not be a positive number. You can very well have a negative number, as in this case. We can see that minus 2, right? And x is common. So minus 2x is your common factor. Pull that to the front. Minus 2x squared divided by minus 2x will give us x. Minus 6x divided by minus 2x squared, right, is going to give us positive 2. Sorry, positive 3, right? And that's what we have. Now, let me just highlight something. If you didn't take out minus 2x, but you took out 2x, look at what happened. Let's say you take out 2x. You will end up with minus x here, right? Minus 3. And this looks ugly. You see how this piece looks? Having a minus in the bracket there, it looks ugly. And that is why, mathematicians say, look, to make this thing look better, we're going to take out a minus 2 rather than just 2. Clear?
Yes, sir.
Follow me? Let's do a couple more. Let's say you have, okay, px plus qy plus, let's go with 3 px minus 2 qy. So look at this. You have to factorize something like this, right? So what they call this, the method you will use is what they say, you group the like terms or you factorize by grouping, right? So look at this. You see px and px common, qy and qy common, right? No, sorry. I have to change this up. I have to change this up because this you can simply add them. I don't want to add them. All right, let me change this. Let me change this. Give me a sec. Let me look for a proper one. Uh, Let me go with PQ plus, uh, no, let me not use PQ. Find one, okay. The same PX, and then we go with QX, right? And then we go with PY, and then we go with QY, right? So we can add, yeah, there's nothing we can add up there, right? They're all different. This one is PX, that's QX, that's PY, that's QY, right? But what we could do, we could group them up. Watch here. These are similar, right? In that they both have X in them. And these both have Y's. So what we could do, we could take out the X from this piece and we get P plus Q. And then we take out the Y from here and we end up with P plus Q. And the fact that we have two common brackets, we can bring that to the front. P plus Q in a bracket and X plus Y in another bracket. See? So we group them up like that. Right? You group them up like that. We group that, we group that. Factorize out the highest common factor, which is X. Do the same here. We notice we get a common factor in the bracket. We bring that to the front. And X plus Y goes in the other bracket. Right? This is a common way of factorizing, right? Factorizing by grouping. Think you follow this one?
Yes, sir.
Don't tell me nothing, man.
Yes, sir.
All right. Let's go with another one. We do another similar one. Factorize ax plus by plus bx plus ay. Look at that. So here it's not immediately obvious, right? But what we could do, we probably can bring the x terms together, ax plus bx, right? And then we put by plus ay, right? Then we group these two up, ax plus bx plus by plus ay, right? Bring the x to the front here, a plus b, and then you do the same with y. And then we have, well, even though they have b plus a plus b and b plus a is the same thing, right? So we bring that to the front, times x plus y. Is that clear?
Yes, sir.
Yes, sir.
I didn't have my headphone on. I wonder if you were hearing me all the time?
Yes, sir. We're hearing.
Oh, y'all were hearing me? Okay, my headphone was not on in my ear, but I guess my voice was going through the microphone. Yes. So this is what you call factorization by pairing, right? By pairing. Good. So I have some other types of factorization, but I think you have to be fresh. You need to be fresh to be able to, kind of follow that. And I'm thinking about the wisdom of going on, and maybe we could leave that for the next day. What y'all think?
Yes, sir.
Okay, let me do that. Let me do that. Because I think the other parts, I didn't want to. I got factorization by what we call difference of two squares, perfect squares, and then I want to leave those for a fresh, a fresh start. Right? All right, let me